Hi everyone, welcome to AMA 3003 Tensor Field Theory. My name is Dr. Dermot Green and I'll be taking the first 6 weeks of the course. The final 6 weeks will be taken by Dr. Andrew Swan. So Andrew and I hope that you've had a wonderful Christmas break and are raring to go for 2021. And let's all hope that this year is a bit kinder to us than last year was. That being said, we still have to deliver our lectures remotely. And our plan was to provide you with a set of pre-recorded videos that complemented our comprehensive set of lecture notes. So Andrew and I have typed a set of lecture notes. They're on Canvas. Everything you need for the course is in the lecture notes, but we thought that these videos could provide you with some complementary insight and at the very least a guiding hand through the lecture notes. So this is just a short video to tell you about the contents of the course and the assessment procedures. So during the course we will define tensors and tensor fields, we'll study their properties, and we'll look at important applications, namely to Einstein's special and general theory of relativity. So the theory of relativity is one of mankind's greatest intellectual achievements, and it's a theory for which tensors provide the natural underlying mathematical framework. So the course itself is divided into 4 well-defined sections. Section 1 is on tensor algebra, and here we consider n-dimensional space, and we generalize scalar and vector fields to introduce tensor fields. And we'll see that tensors are objects that exist independently of a coordinate system, and thus serve to isolate the physical and geometrical properties from those that depend merely on the coordinates. Although they exist independently of a coordinate system, if we choose a coordinate system, then we effectively choose a representation of our tensor. So if we choose a different coordinate system, we choose a different representation. So in section 1, we'll be concerned with coordinate transformations in n-dimensional space and learning how to map one representation of a tensor to another. Section 2 is then about special relativity, and special relativity is a theory about the consequences that arise if we have a coordinate transformation from one coordinate system to another subject to a constraint, and the constraint being on the speed of light in the case of special relativity. So we'll learn about mind-boggling things like time dilation, that my watch will run slower if I walk compared to if I stand still, and that moving rods contract. And we'll also think about how electromagnetism is described in different coordinate systems. So what happens if we transform coordinates? Section 3 involves more mathematical machinery where we develop tensor calculus and we think about curved space. And then in section 4 we develop general relativity. So this is relativity in curved space-time. Regarding the assessment procedure, there will be 8 problem sheets that will be distributed via Canvas, and you can submit solutions electronically via Canvas. And if you do so, you'll receive feedback in the form of a mark and some comments from whoever is marking it, be it me or Andrew or one of the PhD demonstrators. So note that problem sheet 4 and problem sheet 8 both contribute 10% to the overall module mark, with the remaining 80% being determined by the final exam. Okay, so problem sheet 4 and problem sheet 8 both contribute 10%. Okay, and the final exam contributes the remaining 80%. Finally, as this is the start of a new module, it's good practice to mention the student evaluation questionnaires from last year. So Andrew and I both delivered the course last year. It's the same course that we're delivering this year, albeit remotely. So last year the students marked our module evaluation and teaching evaluation questionnaires with an average of 4.9 out of 5. Okay, so across the board, the students were extremely happy. And we very much hope that this year you guys will be as happy. If you're not, if you can see that we can improve in some way or adapt our teaching to tailor your needs in some certain ways, if possible, please let us know. Okay, this is the first time we've been lecturing remotely. Okay, so we're happy to be informed, and we hope that we can help.